All right, so this is 7.3 homework, but I wanted to start out going over a little bit of the multi-step activity here. This is a great activity. It brings together all of our knowledge about triangles and squares and rectangles we've talked about, and really brings it all together. All right, so first we understand, oh geez, dropped my computer. We understand that BCA, geez, okay, we understand BCDA is a rhombus. There we go. That's this guy right over here. This BDCA right here. This is a rhombus, so it follows all of the rhombus rules. This one here is a square, and it follows all of the square rules. This one here is a rectangle, and it follows all of the rectangle rules. It says that RXS is a isosceles right triangle. That means that these angles here are 45 and 45. Okay. It also says that this is isosceles. Well, this is a vertical angle. So I know this is 45, and I know this is 45. That's just what it means to be isosceles and a right triangle. By being isosceles, we know that these two segments are correct, right? We know isosceles triangles are the same. Okay, and then it says X is the midpoint of RW. So here's the midpoint of RW. That means that these two are the same length. Okay. Kind of interesting. That's just setting up from triangles. We knew all this stuff from triangles forever ago. We knew midpoint was there. I want you to try and build this idea up off of your own knowledge. But to help you get started, I'm just going to point out some things that I noticed. X is the midpoint. X is also the midpoint of SV. Oh, so that means that all four of these are congruent. See how this SV are congruent? Well, since it's isosceles, these are also congruent. So they are actually all one single congruence. Interesting. So it says, use the information and the diagram above, as well as the definitions and theorems about parallelograms, rectangles, rhombus, and squares to complete the congruent statement. All right, so let's look here. It starts out here with a BD. BD is right here. What is BD congruent in a rhombus? Well, a rhombus has all four sides congruent, so I could say BA. Well, if it's all four sides, then that's also AC. And that's also CD. Each of these are segments because we're using congruent symbols. And then once I get to CD, I can say all of these are congruent. Check this out. Now I go around, this is a square. Squares have all four sides congruent. So CD also is congruent to CL. And LP and PD. Cool. Now, rectangles have the same side across, or this is a rectangle, so we say they have the same length across. So PL is congruent to RS. That's a Z, sorry. Okay, and we know that RS and SX are congruent because it's an isosceles triangle. So here's SX, and I know that SX and XV are congruent because it's the midpoint. So I say XV, and then I say VW and VX are congruent because it's isosceles. So we say VW. Look at that. All those things are congruent. I put the symbol above it. Sorry. There you go. Because they're all segments, because we're talking about congruence. So that's kind of cool. Right off of that, I know all those are congruent. Now, if I go through and I find individual pieces like this, it says LS. Here's LS. What is LS congruent to? Well, it's a rectangle, so we say it's congruent to PR. Now I look specifically at PS. That's this segment right here. Well, that's congruent. In a rectangle, the diagonals are congruent. So I say PS and LR are congruent. BF, well, let's see, BF. Ooh, that's just this portion of it. This is this half. In a rhombus, they bisect each other. So BF is congruent to FC. And then I say AF is congruent to FD. Terrible looking F. Okay. So FD is the other part. Now it says Rx. Let's find Rx. Rx is congruent to what? Oh, it's the midpoint. So we know it's XW. Okay. So actually, let me make these 3. Make sure they're not the same. What else? What else are they congruent to? Oh, if you'll notice, it's a 45, 45, 90 triangle, isosceles right triangle. That means that this length here has got to be the same as DL. Ooh, this is a cool puzzle. DL, because this is a single line, and it's a 45, 45 triangle. So it's DL, and also CP. Those ones are also congruent to each other. So they get little 2 markers because they're congruent. CH appears to be this halfway point. CH, so that's equal to the other halfway point, which is HP, and also DH, which is this piece over here, and also HL. Same here with this LJ, gives us JR right here. They're halves of the diagonal. And then we say that's also congruent to PJ and JS. Well, that's kind of cool. That's all your congruences. Now we get into angles. BAF is this angle here, and it's congruent to the others because it's a rhombus. Rhombus means we bisect the angles. So I say angle FAC, and they're also equal to this other side over here, which is going to be BDF and FDC. That's just off of the rhombus. We've got those 4 are congruent. Now BAC is here. BAC is there, and that is congruent to the other side, which is FB. Oh, excuse me. My apologies. I read that incorrectly. BAC. BAC is over here. And since it's a rhombus, opposite angles are congruent. So that's congruent to BDC. Whoa. Look at this. BFA. BFA is this guy right here. It's a 90-degree angle because it's a rhombus. So now it's asking me to list all of the 90-degree angles in this picture. There's a ton of them. So we say BFA, we say CFA. Let me make that F a little better. CFA. That's just the other side, CFA. And then we also can do around the other side, we can say BFA, CFA, oh, sorry, CFD, EFD, and CFD. There we go. That's these 2 over here. And it just goes on and on. Every right angle. All the 4 angles here are going to be 90. On a square, these are also 90. So there's another 4 we could name. The outside angles here are all 90. This one's 90, and this one's 90. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 total right angles in this diagram. How cool is that? All right, so now it says HDP. Here's HDP is this angle here. Now these ones are all your 45s. Okay, that's going to be each half of these. That's 1, 2, 3, 4, 5, 6, 7, 8 of them. Then you got this is 9, 10, 11, and 12. So there's going to be a total of 12 45-degree angles in this picture. Now it says PJL. Where's PJL? Is right here. It's congruent to its vertical angle there. PJR is up here. This is congruent to this one down here. They're vertical angles. ABF ABF is this piece here, which is congruent to its oval sides. So there's 4 of those total, and this picture gets more and more involved. Now we're talking about triangles. Oh man, triangle BFA. That's this triangle right here. I wonder if I can change colors. Probably should have done this all along. This is now triangles. This triangle right here, I'm gonna do it even bolder. BFA right here. What triangle is that congruent to? BFA. It's going to be CFA. Now this one does have to be in the correct order. BFA starts across the short and then the long leg. So I say this one's got to be written in CFA. It's also going to be BFD and I think CFD. Yep. Oh, how about triangle RSX? Where's RSX? Here is RSX. You're actually going to have 6 different triangles. You got this one here, this one here. This is another 45, 45, 90 triangle. Here's another one here. Here's another one here. And here's another one here. You've got 6 total triangles to deal with as far as congruence goes there. I'll let you write those all out. DHC. DHC is this little teeny triangle here. And there's 4 of those. 1, 2, 3, 1, 2, 3, 1, 2, 3. Those 4, each individual of these little triangles works. And then PRL. PRL is this guy right here, and he has a mirror here, and he has a mirror here, and a mirror here. So there's 4 of those triangles. Goodness. ABD. ABD is the long triangle here, and it's congruent to this other long triangle here. So there's 2 of those. BAC. BAC. Okay, I'm going to clear all this. Okay. BAC is this one right here. So those ones are congruent. PJL. PJL. Ooh, I like this one. It's got a mirror here. Those ones are congruent. Is that SJR? Looks like. And then PJR is up here. This triangle here is congruent to this triangle here. I'm not asking you for reasons or definitions or proofs. I'm just asking you to use your logic to quickly look at these and see how much information we have on this one. I love this picture, and I love how much information you get off of it for your activity. Oh, excuse me. Okay, so this all needs to be filled in for your notes. Every one of them is going to count. I strongly recommend you do each and every one of them if you didn't make it to class. All right, so for your homework, 7.3 homework. All right, I'm giving you a quadrilateral. It's a rectangle for these first ones, okay? Answer each of the following questions. Show all your work. So if it's a rectangle, we knew special information about rectangles. The diags are congruent. That's the little congruent symbol. All right, so WY is a diagonal, and it's 19. Then the diagonals are congruent, so I say ZX is congruent to, oh my goodness, 19. Now here, if I have WY is 18, again, that's a diagonal. So, oh, but it doesn't ask you for the other diagonal. It asks you for WT, which is half of the diagonal. So if it's 18, and I'm looking for the half of that, it's going to be 9. TX, interesting. TX is 7. I want to know WY. I want to know this whole length here. Well, again, we can do 7. That makes this 7. That makes this 7 and this 7. All the diagonals are cut in half, and all of them are equal. So the whole thing from here to here is 14. Ooh, I like this next one. Oh, man. Going everywhere. All right. We say WY. That's this piece right here. And then we're talking about ZX, which is this diagonal over here. We know the diagonals are congruent to each other. So I come over here and I say 3A plus 16 is equal to 5a minus 8. Well, I subtract 3a, subtract 3a, I get 2a here. I add 18, and I add 18, and I end up with 34, looks like, 34. And that equals 2a. Divide by 2, divide by 2. A equals, 17. Okay. Important part is that the diagonals are congruent. Now we're shifting gears. Now we're saying it's a rhombus. So if ABCD is a rhombus, we know some more information about rhombi. We say that they're, oh man, thinking I'm right, but I'm not. All right. For a rhombus, we know that the diags are congruent because it's a, oh no, that's a rectangle. My apologies. We know that the diagonals are perpendicular. And we also know that they bisect the angles. That's the angle symbol. All right, so now let's take a look. AD is right here. Then what is AB? Well, it's a rhombus. All four sides are the same length. So AB's got to be 13. Measure of angle 4 is 25. Okay, well, 4 is right here. And if 4 is right here, this is 25. We know that it bisects the angle. So I know that 5 also has to be 25. So I say angle 5 is equal to 25. All right, DAB. DAB, this whole thing up here is 130 degrees. Then ADC, ADC, interesting, okay. This is bringing in some old information. So this whole top angle, DAB, this whole thing here is 130. It's asking you for ADC, that's this angle here. Well, notice how they are supplementary angles. A rhombus is still a parallelogram, so this still has to add to 180. So I say 180 minus 130, and I end up with 50. So ADC has to be 50 degrees. So here I say angle 4 is right here, and it's 3x minus 2. Angle 5 is right here, and it's 2x plus 7. Since it's a rhombus, we know they bisect, so they're actually congruent to each other. We set them equal. 3x minus 2 is equal to 2x plus 7, and we do the algebra and find out that x equals 9. Subtract 2x, subtract 2x, x equals plus 2 over here, plus 2, x equals 9. Okay. Not really that interested in those little minor details. I'm more interested in making sure we understand how these shapes work. So angle 1 is 5x plus 18. Angle 5 is 3x minus 8. That's this angle here and this angle here. Interesting. Well, if I look at this a little bit closer, I think I could do some vertical angles. Oh, I'm sorry, they're not congruent. That's just what we're talking about. My apologies. 5 is, however, congruent to 4. And 1 is congruent to 2. So I can say those two are congruent and those two are congruent. Well, both of them together and both of these together have to add up to be 180 degrees. So I would say 2 of the 5x plus 18s, it has to be added to 2 of the 3x minus 8, and all that has to equal 180 degrees. Interesting. So this is actually going to cut out in full be 10x plus, what, you can't even read that, honestly. 10x plus, what is that, 9 times 4, 36. And this one's going to become 6x minus 16, which is really going to combine to be 16x plus 20. All that's got to equal 180. Subtract 20, subtract 20, that's going to give me 160. Divide that by 16, and that's going to get me x is equal to 10. Sweet. Good question. Okay. So, angle 2 is this, angle 4 is this. It's the same process. We just have to recognize that angle 2 and angle 1 are the same size, and angle 4 and angle 5 are the same size, and therefore 2 of these angles plus 2 of these angles has to add up to the 180. So if I times this one by daggone pen, all right. So I say 3y plus 9. I times that by 2. I'm going to get 6y plus 18. And then I times this one by 2, and I get 4y minus 8. I combine them together to get 10y plus 10, and that's equal to 180. I subtract 10 over here, I get 170. Divide by 10, and I get y equals 17. Man, I gotta figure out how to fix this pen because it's driving me crazy. So for number 11, it's a square. We have increased information about squares. MJ is 13. Find out those other two numbers. So if I say MJ is 13. If that's true, then I'm going to say that JK, well, all the outsides are all 13 too. So ML is 13 and LK is 13. You didn't even help that one. MX is 8. If MX is 8, then how big is XJ? All the diagonals are congruent. Okay, and since they're congruent, we know that XJ is also 8. Because 8 here, 8 here, 8 here, and 8 here, they're all 8s all the way around. Okay, and then we have here mx equals 8, then xj equals what? Mx is 8. Oh, it's a repeat. It's the exact same question over here. Perfect. So, easy question. Alright. Find out what's next. Alright, we're still doing squares. So that means I'm going to want to come up here and say mj is 13, ml and lk. Oh, that's the same as the first one. JL. JL is all the way across. It's 18. Well, the diagonals are the same. This is 18. Half of 18 is 9. And that's equal to the other part. Alright. So here I have JL is 18. These are the exact same question. I'm confused, but I'll go with it. 18, JL is 18, then MK is the other diagonal, 18, JX is half, and XK is half. Yeah. Alright. I guess we have some repeat. So now, if we look at the shape here, if the numbered angles are congruent, then each angle has what measure? Okay. Angle 1, if all of these are congruent, then each angle has what measure? Angle 1 equals 45. If all the numbered angles, so 1, 2, 3, 4, 5, 6, if all those numbers are all congruent, then they all have a measure of 45. And you go through and you mark them all as 45, whatever. Okay, so they're all 45 degrees. if I'm reading that question correctly. That's the real question. Alright, now this is my favorite part. This kind of breaks down our understanding of what it means to be each of these in the list. Equiangular. A parallelogram is not necessarily all angles are equal, but a rectangle is, and so is a square. Equilateral. Again, parallelogram not so much, but it is a rhombus is equilateral, and a square is equilateral. Equiangular and equilateral, well, that's only a square. Opposite angles are congruent. That's a parallelogram, and a rectangle, and a rhombus, and a square. Opposite angles are congruent. That's true for parallelograms, and rectangles, and rhombuses, and squares. Diagonals are perpendicular. Now that only works for a rhombus and a square. Diagonals are congruent. Ooh, that starts with rectangles and squares. Diagonals bisect each other. That's a parallelogram. And if it's true for a parallelogram, it's also true for all of them. Because guess what? All of these are parallelograms. Anyways, diagonals bisect opposite angles. That starts with a rhombus and continues into a square, because a square is a special type of rhombus. Regular polygon. Ooh, which of these four is a regular polygon? We discussed that a regular polygon is equilateral and equiangular, so the only answer can be square. And I believe that finishes your homework for 7.3. Hopefully you didn't just watch this. Do your homework. This should help you if you get stuck. And do your notes, do your homework, and we'll see you in class.